It seems. It seems to me. Right, so we are on here. Let's see, I have to switch on screen share. You guys all here, that's great. I'm glad you have decided to still come to class. Come on. No, man. I want to switch on Q&A. There we go. Q&A. It's on the side, and I'll notice questions. And when there are questions, I'll start answering them. We have so much to do today. It's so exciting. So where to start? Let's start with the test, the written test, because that's what you did first. I've marked the written test completely. The marks are on Sun Learn. If you can't find them, please contact me. If you haven't written the test yet, I think one person sent me an email. If you need to write the makeup test, you must contact me. Otherwise, you won't be able to demo your project either. It's critically important. One more thing, and that is that I am really happy about how well the test went. It wasn't too difficult, was it? Excellent. Everybody in class is a bit easy. Now, how did you do? So I will put stats on the website, on our website, but I can at least show you the distribution of marks. Can I? Yes, I can. This is a distribution of marks for the test. So the majority of the class had at least 50%. Majority had at least 50% or more, and that's enough for me. If I can pass 50% of you, every odd one, let's say, in a row, then that's enough, isn't it? No, it's not. I have to pass at least 80% of you. Otherwise, I'm fired. The university will fire me. They'll reduce my salary by half if I fail 50% of you. It doesn't matter how many pass or not. I really want you to learn to program. I mean, all of you. Even if you fail the course, even if you don't carry on with computer science, I really want you to program because it's so exciting, and I find it the best thing in the world. But you don't have to. But still, it's exciting stuff. Okay, so that's a written test. Now, the practical test hasn't been marked. I'm not really happy with it. Not with you guys, but with the setup. I mean, you can't have a test like that. So I'm not sure what we are going to do, but we are too many for the lab. That's the bottom line. And next year will be worse because there will be 300 first years doing computer science. So it's not getting better. We'll have to do something, but we'll see. Probably it won't be in time for the last practical test. Okay, so this is still going on, and everybody's happy with that, and no questions. Now, in case there are questions, I will prove to the people at home. There is my egg timer, and I'm setting it to like 7 minutes. It's ticking. Good, right? Everybody trust me. That's the egg timer set. Those are the marks. Now, next important piece of admin. This is our website. No, it's not. This is our website. Yes, it is. Excellent. And I have started adding all of the lectures that Dr. Hoffman recorded in 2012 in the university's television studio. He recorded these lectures, and they're all online. They're much better than mine because he actually talks sense and he doesn't talk nonsense. He goes through the work at a nice pace, and you should really have a look at those. And they're indicated here, lecture 3.1. These two seem to be missing, but I think that these are not real lectures. I mistakenly thought that they were lectures, but the rest are here. The slides will come in due time. Our recorded lectures have links on. I still need to add the class notes for last Wednesday and last Friday, but I have them scanned. I just need to upload them on the web. So the website's looking better than before. I've also actually started adding news at the bottom, and the resources page will now list all the slides, all the class notes, all the videos, all the code, some data files for the tutorials, and also things like the test memo, test itself and the test memo. So they can say that in perpetuity. I don't mind giving out old tests, but I didn't want to give out previous test for Monday because I thought it would scare you. I mean, the previous tests were much longer, like 6, 7 pages long in one language, and I didn't want to scare you guys too much. New lecturer, new tests, new beginning. Okay, so I've started adding news, as I said, and we'll look at that in a second, and I may have started updating the FAQ. Slowly but surely, I'm working through my emails. My life is only now catching up with the start of this course, and soon I'll be caught up and ahead of all you guys. Now, other piece of news, project demos. Project demos. Okay, let's go here. So this is the project spec page. It's all beautiful in that. This is the marking scheme, which you ought to know. And then I've added project demos. So you must submit your project before 10 to 2 on Thursday. At 10 to 2, the system will shut down. It's a cutoff. You won't have a late submission. You simply cannot submit anymore. Okay? And if you don't submit by 10 to 2, you will receive 0, unfortunately. Yes, Marie?
Are we allowed more than one submission?
I don't think so. I'm not sure how the system works, but I think it's only one submission per assignment. You can try your luck easily by submitting your right answer and then later you submitting the same answer. But I'm not sure. Yes, Josh.
Do we submit it as like a zip file, like we did for the back?
Your project exported as a zip file.
Yeah, but what if it didn't work in Eclipse?
Then I want a zip file of your source directory. As for the project as well, a practical test. People didn't have to use Eclipse. Okie dokie. Now, demos will be during our tutorial on Thursday in Narga D. It'll be chaos if we all show up at the same time. So you're not allowed to come to Narga D. Unless it's your time. So here are the times and people that are going to mark your work. So you can see here it says 2 o'clock, this person, 1565, 2602. Are you in class 1565, 2502? Where are you, 1565, 2602? Not here. But let's say this person, 1772, 3795. Are you here? Too shy to say. Okay, fine. In any case, this is a numerical order. It starts here and goes across. I simply allocated you like this, no preference. One person said that they can't demo early, and you must come to me, you must notify me, because otherwise I've forgotten your name and your number, and perhaps I still have your email. I'll check for that, but you may be scheduled early and I don't know about it. Also, your number won't be up here if you haven't written the practical test, or the written test rather, which is what I base the class list on. I'm assuming that if you're doing this course, you would have written the first test, and that's how I got these numbers. All right, so there is your time. Let's say let's find a nice number. Oh, no. Yeah, here we go. 1712 4999. Okay. 1712 should go to Jared, who will be in Nargati, and I'll make him wear name tags and posters at 10 past 2. So 1712 4999 must show up at least 5 minutes early. So 5 past 2, he or she must be there and log into a computer next to Jared, so that Jared don't have to wait for you to forget your password, phone your mother to ask what's the password, all that kind of stuff. Okay. If you are late, Jared will subtract marks. You won't have any choice. It's on the marking scheme. Okay. Here comes 1712 4999 just in time. Yes. Near. Whenever you does the zip file have to have a special name? Whenever you upload something to SunLearn, your old names just go away, and it's given some kind of internal name, which is your student number plus assignment name. So I don't even see your old names. I don't care about your old names. You can call it whatever you want. Okay. Do you have any other questions about the project? kind of exciting. Who's finished? Let's just see who's finished. Some people, and some people just lowered their hands again, so that's not entirely finished. If you are still struggling, and I have received emails from people, and I'm in the process of answering them, time for a question online. Or did one of those people, oh, here we go. Some exciting questions from the internet. I'll do this, I'll answer them soon. One thing, people have sent me questions about the project, and I'm only getting to them. I will get through them today. I'll put them on the web if they're generally interesting. And some people ask for extra help, so I've arranged with the demis, the assistants, to be in Narga H tonight, tomorrow night, and Wednesday night. So they will be there from 6 till 9. If you have serious questions about your project, then you should go and talk to them. There'll only be 2 there each night. We only have so many demos. So I'm hoping they'll help you in a group all together. But maybe they'll give individual attention. And please don't ask them to explain everything from the start, because 1, it's too late for that. 2, they have a lot of people to deal with. And they'll also be there, I think, Thursday morning in case somebody erased their whole project. And they're just crying. They won't help you, but they'll comfort you and say, you know, it happens to all of us. Also. Okay, let's see. Okie dokie. When will be, let's start, just handle these questions because you probably think the same thing. When will we be getting our test back to see where we lost our marks? No, I want to keep those tests because I have to keep them for my records. But honestly, you're welcome to come and look at them. Actually, they're still at home, but tomorrow I'll bring the box and put it in my office, and you're welcome to come and look at them. Please just make an arrangement. Just send me an email, not for my convenience, just so you're sure I'll be in the office because I am teaching a lot. I'm out of the office a lot. But I don't want to give you your tests. I know it's bad and you want to check when you lost marks, but my experience actually not many students want to do that. So I think it's best if you come to my office. Okie dokie. Let's see. Next question. Zintler. I can't find my marks. Could you please give your email address? Oh, that's kind of stalking behavior. No, I'm not giving out my email address, even though it's on the website. But if you can't find your marks, please check that you can find your marks. If you log into Sun Learn, in fact, perhaps I should do that right now. I'll just log into Sun Learn and see what marks I got for the test. I'm sure it must have been fabulous. Oh, Sun Learn. There we go, Sun Learn, that's it, yes. I want to see, I have to log in. So this is tricky because this window is bigger than my screen, but don't you worry about that. Log in. Yes, sign in. You can't see it, but I'm signing in. There we go. And what courses am I doing? I'm doing that course. Okay, so now we're on the main screen of Sun Learn. And if you go down to the side, oh, no, hang on. I'm just going to switch my role to student. I'm a student, look at me. Okay, so there's the project submission, but it'll only open tomorrow morning at 8 o'clock. And if you go down here at course administration, you can see your grades. Let's see what I got. Oh, it's going to be so good. Oh, let's see. What? No grade. Okay, so I got 0 for the test. Apparently my answers aren't good enough. But you'll see your marks here on this report. So you must have used Sun Learn before. So go to the left-hand side, administration grades. I'm sure you all know exactly how it works. And Zintler, if you can't find it, then yes, please send me an email because it's something serious. Okay, let's go back to Google Hangouts. So also I'm done with Zintler. That's helpful suggestion for Zintler. Grades on the left-hand side. I'm sure you've done it before. Tato, can we demo from our own laptops? No, thank you. I prefer you to come and log in and have the Demi mark your code on the system. Because it has to be on the system. Plus, it's much more convenient for Demis if there aren't lots of people dragging laptops around. So let's just do it on the system. Unless you don't do it on the system. Let's see. I did that, Shane. There's nothing. I'm also not on the demo schedule. Zintle, but then you haven't written the test. And you must send me an email to write the makeup test. Okay. Hi. On the home of the website, there is a blue section with nifty stuff, yet the links do not work. I know. I'm so sorry. Let's handle this question. I'm still getting to the nifty stuff that I have to post. And there's lots of stuff from last year that is also still nifty. And I'll post it soon, I promise. But it's the least important because it's just extra interesting stuff. I'll talk about some nifty stuff in a second. If you have not done so, I'm not sure exactly. Let's just pretend that I've answered those questions. This is Shane. But I'll just mark them as done. If you have not done so, thanks. Good. Okay, excellent. So our friends on the internet are happy. I'll check in a second. Let's give it 10 minutes. I know it's long, but it's hard life. Okay, right. Okay, anything else you want to know about the demo, the project, the tests? Anything else? Everybody happy? Excellent. Okay. Now, let's talk about not binary search, because we've done that, but we're supposed to talk about sorting. And remember, the idea of sorting is you have a list of items that can be numbers or strings, or actually much more complicated things, and we want to get them in the right order, in alphabetical order or in numerical order, sometimes descending, sometimes ascending, from small to large, from large to small, and we need to know how to sort. And we definitely need to do this to do binary search, because binary search only works if we have a sorted list. And then I mentioned bubble sort, and I said it's terrible, you shouldn't learn about it. But I've kind of changed my mind over the weekend. I'm prepared to give bubble sort another chance, which is why I went to the pharmacy this morning and I bought the special bubble sorting kit. As you can see, this is Melissa and Doug, magnetic wooden numbers. And we are going to use this precious commodity today to learn to sort. Okay. So I'll have a 3 and a 1. No. Oh, that is absolutely stunningly beautiful. Okay? Excellent. So we're going to learn to sort numbers. We could sort strings, but numbers are going to be easy. R, for me to manipulate. So, bubble sort. How do we use bubble sort to sort these numbers? Well, bubble sort is actually quite easy, as you'd expect. I was going to do this with students and heights, but then it's too difficult to have the people at home see, so we're back to the patterns. So bubble sort says the following. This arrow needs to be sorted. So let's start at the start, and if we find any numbers, any pair of numbers that's not sorted, we swap them. We just exchange them. So I start at the start at 3, and 3 and 5, are they sorted? Yes, 3 is smaller than 5, they're in the right order, so no problem there. Move on to the next pair. 4 and 5, are they sorted? No. So I will need to exchange them. And also remember that I've actually now swapped something. So I know the array is not sorted. Move on. 5 and 1, right order? No. Okay. I'll have to swap them. Okay. Move along. 5 and 1, sorted? No. So I swap them. Okay. Now I've passed through the array once. It's still not completely sorted. Because I know that because I've got a little flag that says I had to do some swapping. And it may still be unsorted. So I clear my flag and I try again. 3 and 4, sorted? Yes. 4 and 1, sorted? No. So we have to exchange. That's called a bubble. I'm bubbling these numbers up and down. And I set my flag. 4 and 1, sorted? No. So exchange. 4 and 5, sorted? Yes. But I'm still not sure this whole array is sorted because my flag is set. So I try again. I move to the start. 3 and 1, sorted? No. So do a bubble. 3 and 1, sorted? No. Do a bubble. 3 and 4, oh, flag. Sorry. Yeah, thanks. Should have put that there first. I mean, obviously Java won't work like that. When you make an assignment in Java to a flag, it updates it immediately. It doesn't go, oh, I forgot to update the flag 2 statements ago. So I apologize for my un-Java-ness. 3 and 4 sorted? Yes, they're fine. 4 and 5 sorted? Yes, they're fine. Flag is set. I still have to make some changes. I'm still not sure that this array is sorted. So clear the flag. 1 and 1 sorted? All together? Yes, excellent. 1 and 3 sorted? Yes. 3 and 4 sorted? Yes. 4 and 5 sorted? Yes. Pass through the whole array, no flag, and I can stop. Because I know that none of the no two elements are in the wrong order. And that is bubble sort. So we can imagine there will be one for loop to work through the array, but only up to the before last element. So we don't have to go all the way through the array, only to the last one, or penultimate one. And there will be another for loop that keeps on doing this. So I'll have my bit for loop that keeps on going through the array. Inside that will be one for loop that scans through the array. And inside that inner for loop will be an if statement that says, if the element I'm at now is more than the next element, swap them. And set the flag if you do that. Okay, everybody happy? That, ladies and gentlemen, is bubble sort. Let's just reorganize these little so I won't be jumping around too much. Good. Okay, that is bubble sort, and we never have to talk about it again. It's not good. What we want to learn about is called insertion sort. So, I mean, there are obviously slides about it, and there's even a nice demo somewhere, which I don't think I brought along today. But we're going to do insertion sort with my little numbers again. So let's jumble them again. Let's just find something nice. 6, 8. Cool. Right. Any order, I'm not manipulating them in any way. And there we go. 5, 3, 4, 6, 8. Damn. Okay. Okie dokie. So insertion sort is based on a kind of assumption. And it's based on the assumption that the array is already sorted. Now, I think you can all agree that this array is not sorted. Okay? In fact, let me just make a small change. I just want to make things more exciting. This array is not sorted. So we can't really use insertion sort on this whole array. But we could use insertion sort on a part of the array, because a part of this array is sorted. If I use my trusty other instrument, called my pad, damn, pad is not big enough. Let's just hide the whole, there we go. Oh, that's good. Okay. Is that array sorted? The empty array? Yes. So we could work with the empty array because that's already sorted. Or we could even use the one element array because that's also already sorted. And now, if we tried anything bigger, sorry, no. Let's pretend that this didn't happen. So just go back a little bit. 5, we can work with this array because it's already sorted. Can we work with this array? No, because it's not sorted. 5, 3 is not in ascending order. So now I have to insert. And insert is actually quite easy. What you do is you say, the array up to 5 is sorted, and I've got to insert. Damn, time flies. Let's just see. Oh no! Oh no! Oh no! Questions. I'm not the only one with this problem. Did we make a mistake? In the project description it says, okay, I'll get to that in a second. I promise to get to those questions, but I just want to finish my brilliant insertion sort demo. Okay, so I'm just going to make that big again. I promise to get to those questions. Internet, you've been good to me, and I'll return the favor. Okay, so we have to insert 3 into the sorted array 5. And how we're going to do that is we're going to keep the 3 somewhere in a special variable because it's the element I want to insert. And then I'm going to walk backwards through my sorted array and say, is 3 less than 5? Yes, so there must be some space before 5 in this array for 3 to fit. And I have to move the 5 up to make space for this element. So I'm going to copy that 5 there. And of course, it'll still be there as well. I've just copied it. 3 is stored somewhere else. But now I'm ready. I can move on. I can move on to this empty array, which you can barely see. This empty array. And in the empty array, there's nothing. There's nothing to move up. So I can insert the 3 here. I can insert the 3 right there. And now I'm going to repeat this step. So I look at this array. It's not sorted, but up to here it is sorted. So I'm going to insert the 4. I'm going to make a copy of the 4, and I'm going to say, is 4 less than 5? Yes, it is. So copy the 5 over there. Okay, move 1 back. Is 4 less than 3? No, it's not. So I've got to stop here, and I'm going to insert my 4 exactly there. That's one insertion step. Now we try the next. Array up to here is sorted. Let's try the 6. So I make a copy of the 6. Is 6 less than 5? No, it's not. So I should stop here and insert the 6 right after this point. I didn't really have to move anything to fit the 6 into this array. I look at this array. I want this first part is sorted. I want to insert the 8 into the sorted array. So I make a copy of it. I ask, is 8 less than 6? No, it's not. So I can stop my insertion and put the 8 right there. Cool. Now I'll be needing a lot more copies of my little. And just give me a sec. Okay, right. We inserted the 8 and we're happy. This is a sorted array. So I'm slowly building up my final sorted array. Lastly, I'm at the 1. Up to here, it's sorted. I want to insert the 1 into this sorted array. So I start working from the back. First, I make a copy of the 1. Is 1 less than 8? Yes. So I have to move the 8 up. Now, let me just find the 8. Should have prepared this beforehand. There we go. So I make a copy of 8. There we go. And I move my cursor back. I'm working backwards to the array. Is 1 less than 6? Yes, it is. So I make a copy of the 6. I put it in the 8th place. That will still contain 6. Never mind that. I move back 1. So the 6 is moved up because I need to insert the 1 somewhere before the 6. I move my cursor back. Is 1 less than 5? Yes, it is. So it needs to be somewhere to the left of 5, and I need to move 5 up 1. So I'm going to move 5. Actually, I move that 5 there, and that's my phantom 5 that's still there. Move the cursor back. Is 1 less than 4? Yes, it is. So I have to move the 4 up. There's the phantom 4. Okay. Move my cursor back. Is 1 less than 3? Yes, it is. So I have to move the 3 up. There's my 3. There's my phantom 3. I move back. Now I'm at the empty array, so I can't go any further, and I know 1 must come exactly there. Hide my phantom numbers. So I've sorted this array. I've inserted the elements one by one, starting at the left. Insert, 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 insert. Except the first one, I didn't have to insert that. And to insert each one, I work from the array I have backwards and see if the new number is less than the last number to the left of my cursor. And if it is, I have to move this number to the left of my cursor up 1 to make room for the new number. Do you guys feel comfortable with this? No? Yes.
Would it not be more efficient to have a source array and a target array and then find minimum values that you send into as much time?
So, such a good question. My first computer had 8K of RAM. 8 kilobytes. Not 8 megabytes, 8 kilobytes. And that's about the same memory that the first computer that arrived in South Africa in 1956 or what have you had. So if you only have limited memory, you cannot just say, oh, we'll just make a copy of the array. It'll just be too memory consuming. I mean, if you have an array with 20 million records, each record is a few K, then you'll run out of memory if you do it that way. Plus, memory is really slow. In the computer, there are 3 kinds of memory. Firstly, there are registers, and they're really, really fast because they're inside the CPU. Then there is the memory, what we refer to as memory, which is the RAM, and that's quite a lot slower. And lastly, there is the disk, which is the slowest memory of all. In all 3 of these memories, you can store information. You can store information in the registers, you can store information in memory, you can store information on disk, but they get slower each time. Of course, they also get bigger. We have, let's say, 8 registers on the CPU. We have lots of memory, 8 gigs perhaps. We have lots of disk space, a few terabytes of disk space. So we can store more things, but it gets slower and slower. If possible, we don't want to access too much memory because it slows our programs down. Now, there are many ways that people have tried to speed this up. So we put a cache on the CPU that buffers some part of memory and makes it faster. But that's still a little slower than the real registers in the CPU. It's faster in memory, but slower than registers. And the same thing at the disk. We use part of our memory to buffer parts of the disk. So that when we write files to disk or read files from the disk, it's actually much faster than the disk itself. Now we can access those parts of the disk at memory speeds, but we can only store so much. And all the space we use for this buffering of the disk, we lose in real memory. We're now using memory to buffer stuff. So, of course, you can make a copy of the array, but if it's a really big array, you don't want to do that. It's going to be slow, and it's going to be, you may run out of memory. Okay. I don't feel my numbers have been perfectly convincing, but let's work through the slides. Perhaps it becomes clearer. You guys are so lucky to learn about insertion sorts for the first time. It's exciting when you learn it's a new algorithm you're learning. Next year you'll learn quick sort, heap sort, shell sort, shuffle sort perhaps. All these things are waiting for you, but at least this year you'll learn insertion sort, and tomorrow, Wednesday we'll talk about merge sort as well. And I'll get to the projects on the internet soon, but just give me a sec. So let's just quickly revise. On this slide, we have a sorted array up to element 5. Well, the first 6 elements are sorted. And had, him, his, was, you, all in alphabetical order. And we now need to insert the into this array. So we start from the back and say, well, the is less than you, so you will have to move up. So I can fit the in here. Now, on this slide, they've actually put the in the same spot as you. So they've bubbled down the. But in real implementations of this algorithm, we don't even need to store the in the array. It's okay to leave a copy of you there, because we'll either move something in its place, as in this case, was is going to shift up into this spot, or we'll, once at the end, put the in this spot. Let's see. The is less than you, so I move the u up. Now I'm comparing the and was. The is less than was. It comes before was in the dictionary. So I move the was up here. I can't click here, sorry. And finally, I compare the and his. It's not smaller than his, so his can stay where it is, and the will come into exactly this slot. Will come into exactly the slot number 4. So that's one insertion of the into that sorted array. And here is the whole process, sorting the whole list of words, not showing the insertions, but just showing the final result. So we started with this array where only element 0 is sorted. We can't include element had, because element 1, because had comes, this is not sorted. Was, had is not sorted array. So only the one element array is sorted when we start. And if you think about it, a one element array is always sorted. It contains one element and it's in ascending order. Okie dokie. So now I want to insert the had. Was will have to move up, so the had comes in that slot. Now I want to insert the him. So was moves up and him comes into this slot, and had stays where it was. This is confusing with was and all these words. Now I want to insert the and. So was, him, had, they all have to move up. Had, him, was. So the and comes into the very first slot. I want to insert the u. No one has to move up. On this line, the whole element is already sorted. The whole array is already sorted. I want to insert the his. That'll go right after him. So these two elements have to move up. U moves up. I want to insert his into this array. So u moves up, was moves up, and his goes into that slot. Next, we insert the. So these two elements move up again. U and was moves there, and the comes in that slot. And lastly, I want to insert the but. So u moves up, was moves up, the moves up, his moves up, him moves up, had moves up, but and stays where it is, and the but goes in that slot. And now the array is sorted. Is this confusing or complicated? Okay, perfectly clear? Not perfectly clear. Come on, it's clearish. Can implement it immediately in Java. Sad face. Okay. Oh well. Let's look at the code. So sort. I start with the length of my array. I store that in n. I'm just going to set the timer in like 3 minutes. I'm going to start talking about the internet questions. I'm not going to set a timer, but I'll remember. So n is the length of my array. I have one for loop that starts at element 1 and goes up to the last element. So that'll be the element I'm inserting. Next, I'm going to insert element I. And I starts at 1 because element 0 is already sorted. I don't have to insert element 0. Okay. And what do I do with element I? Well, start at index I, which is where the element is at the moment, and until we get to 0, decrement j. So j starts at the element's current position and works backwards. If the previous element is greater than this element. So the one at j minus 1, which is the element before, so this is element I at the moment, and j is working its way back from I to 0. Oh, it's not. Why is it not? My hand. Okay. Okay, it seems we have a slight camera problem, so but this is still alive. Did I freeze it in some way? Did I press a magic button to freeze it? Undo the last action. Okay, I'm sorry guys, I don't know why the camera stopped working like this. Well, let's just clear it and see if closing it, opening it again will help. Yes?
I was just going to ask if you tried turning it off.
I know how to work with computers. Recording tools, no. Capture. Capture failed. Oh, that's it. Okay. Exit, yes, and let's start again. Oh, keep talking. Here we go. Okay, that looks right. There's my hand. Beautiful stuff. Okay, let's just make sure the internet is still with us. Yes, everybody's still on the internet. And screen share is still set to desktop. Yes, that's beautiful. Good. So I was going to say, we are at element J. Sorry, this is element I. I is working its way, starting at the 3, at position 1. It's working its way up the array. So it's going in that direction. And how do I choose a different color? Never mind. This is J. It starts at the position I, and it's working its way down. And we're asking, is the element at position J minus 1 more than the element at position I? And if it is, we have to swap. So let's just go back to the code. If the element at J minus 1 is more than the element at position J, then we swap. And when we repeat the for loop, we'll be decrementing J. But if it's not, if that element is not less than or more than J, if the last element is not more than this element, we are going to break immediately, and then 1 will be in its correct position. The element A, J will be in the correct position. And this is simply the implementation of exchange. We'll talk more about this on Wednesday. Let's just turn to the questions, because so I guess I have to start at the bottom. I'm quite sure I wrote the test, but I'll contact you ASAP. Excellent. If any of you have the same issue in class or on the internet, please send me an email. Right. Now, I'm done. Hang on. So, next question. Selecting question, please wait. In the project description, the specifications state, if the outcome is 17, return a random constant in the range -1 to 1 in the random method in the expression class. However, this creates artwork which does not look, oh, very good. It looks better without it. Okay, I tell you what. This is about art, and beauty is important. And if you feel that you can make better art than the project specification, then just add the feature, keep the feature, but turn it off for now. You can even have a little button where you can turn it on and off. Just like you have a button that switches between HSV and RGB. Yes?
Hulle maak dit julle random, soos as hulle evaluate direk dan maak hulle hom random. Hulle hou nie konstant Ja, kom maar, ek wil sien baie mense doen dit, dan in die evaluate method van die constant, dan sit dit also random, create random.
Bad students. So, I know. I'm not also saying that Werner Warlock is doing that. But, very important. You create an expression using the random routine of class expression, and that creates an expression for you. And then when you are drawing an artwork, you evaluate the three expressions, the R expression, the G expression, the D expression, without regenerating those expressions. They have to stay the same in the sense that the expressions don't change, although the X and Y parameters change, and obviously the return value changes. The fact that the return value changes is important because that determines the color which we're going to plot. Otherwise, it would be all blue or all. So that has to change. Return value changes, X, Y coordinate change, but the function itself should stay constant for the life of the artwork. It's only when you create a variation of an artwork that you are going to change the expressions in that artwork. Once they are fixed, they stay the same for that artwork. Okay, I hope that's clear, Werner. Okay, right here. Let's go down the list. I am not the only one with this problem. Did we make a mistake? Yeah, I think so. Well, I'm not sure. And then he says, thank you, Julian. No, private communication. I shall see if I have the same problem. No. Let's see. Julian answered. Let's do this question first. Hi, Werner. I had the same problem and managed to fix it. The problem for me was that my evaluate function for the constant class had a math.random. No, okay. So there shouldn't be, it shouldn't return random values. If I send the same two parameters, x and y, let's say 0.5 and 0.6, to a function, whether it's a constant or a sine function or a cosine function, it should always send back the same value. When I created the function, I used a random number generator to create a random function for me. But once I have a function, it should always return the same value for the same parameters. If I say sine of 0.6, it returns some value. It returns 0. Okay, let me choose another. I don't like 6. Oh, why can't I have nice stuff like other people? One. I want a big O because it's an O. Bad. I should switch to whatever I switch to. Thanks, guys. Rad. Okay, 1.4. Sine of 1.4 is 0.8985. And if I calculate this again on my calculator, I get 0.985. And it'll keep on giving me 0.985 because even though the sine function might have been a random choice, it always returns the same value for the same parameters. In the same way, a constant always returns the same value for the same parameter. And constants are even worse in that sense because they always return the same value for any parameter. Once you've chosen the constant, it stays fixed. Okay, so that's Julian, and he managed to fix that. And it's a different issue than what I understood Josh said in class. Because Josh said in class, they create a whole new function every time they evaluate it. But in this case, they didn't really. It's just that the implementation of constant was wrong, and it included a random number generator. So let's say the pixels right next to each other have different constants. Yes. Okay. An instance variable generating in the constructor. Okay, that's fine. That sounds rightish. And Julian helped us to answer that. That's fine. I still don't feel entirely comfortable with how we're dealing with these questions. He says it's clear, thank you. Obviously, it's not best technology, and the fact that I have to use an egg timer with the high technology also kind of ruins the show. But never mind that. Listen, I have to stop now. Are there any other questions about the project? I'll try to have 2 demis in NACA H tonight, and you have to submit by 2 o'clock on Thursday. Thank you very much.